All right. So, like I said before, we're going to do a review, um, and we'll go through the questions that are on the quiz. Please do take notes about what we talk about, but then put them away before you take the test. Just it'll help you and it'll help us know where we need to focus a little more attention and where you're, struggling a little bit. So, yeah, you can use your notes for the review. You can add to them, but we'll start from. I'll just start going through the questions, and I'm gonna do some random checks. I'd kind of like everybody to have a chance to answer something. So if you've answered a question, let somebody else answer until we've kind of gone through the rotation once, just so everybody has a fair chance to answer. So, anyways, so according to the FARS, what are the three things that the dispatcher is solely responsible for?
They are responsible for, is it the MIC? Yeah, the monitoring progress, issuing necessary info for safety, and canceling or redispatching.
Okay, perfect. Okay, let me see. All right, so name three things that constitute a suitable airport for diversion purposes.
I never even heard about that before.
Yeah, what?
Runway length, air stairs, passenger services like bathrooms and different things, maintenance, those kind of things.
Yeah, so did everybody get that? So we went over this, I think, was it the Monday or Tuesday? It was probably Tuesday. But yeah, so basically what we want to make sure we have is the facilities to take care of the aircraft once it's landed. So if we have to say we're en route and an emergency comes up, or we run out of fuel, we're running low on fuel, or the weather at the destination falls below our minimums, then our diversion airport or alternate basically has to be able to facilitate that aircraft once it gets there, facilitate the aircraft and the passengers. So, so you want to make sure that the runway is long enough. You want to make sure that there's fuel, the right fuel for the aircraft. You want to make sure that it's within the range of the aircraft. You want to make sure that weather at that airport is sufficient, above the landing minimums for that airport. You want to make sure that, there's somebody there to receive the aircraft, so like air stairs or what have you, to take, help the passengers get off the aircraft, things of that nature. So just kind of think about what would the requirement be for getting, taking care of that aircraft once it gets there. And, there's a huge list of things that we'll take as answers. So, does anybody have any questions on that?
So what's the For that answer, what was the question? Just so I can kind of get familiarized.
So name 3 things that constitute a suitable airport for diversion purposes.
Okay.
So
So I'm just going to chime in just real quick on this specific topic. One thing to kind of remember with this is there's 2 different things you're really looking at with like a diversion type airport. First off, you're kind of looking is what's the nature of the diversion? Is this an emergency? Is this something where we got to get this plane down onto the ground as soon as possible, or is this a medical emergency? Is this a mechanical emergency? So there's obviously a whole slew of different reasons why you might divert, and depending on the nature of the diversion is going to also depend on the nature of the suitability of the airport. So just take that into account, I guess, when you're thinking about when the question is asked, what constitutes, name 3 things that constitute or that make an airport suitable for diversion purposes. The first thing that's really going to just matter, what's the nature of the diversion. In some cases, if you're having a mechanical emergency, you're not going to really care too much about, certain aspects, I guess, like having medical personnel available and things like that. Sometimes it's just, you just need to divert to the nearest suitable airport. So going back when you guys were looking at the FARs, I know you guys are kind of just reviewing this for now, but one easy way to one good way to remember this specific FAR is just suitable is the FAR specifically says a suitable airport. And the furthermore, it says in that same FAR, it says, it not necessarily in point of time or distance, so it's not necessarily saying divert to the nearest airport. It's saying divert to the nearest suitable airport, and the nearest suitable airport isn't necessarily always the closest airport. So a lot of it is just going to come down to the discretion of the dispatcher and the piloting command of just making that decision. But I'll tell you this, 95% of the time, this is going to be the dispatcher making this decision. Is the suitability of an airport, has to quickly look, find something, and depending on what's going on, he's got to find an airport that's going to suit the needs of whatever they're diverting for. And so, usually the dispatcher will quickly look and then relay that information back to the crew and say, okay, go here. This is, and you have to be able to stand by the decision, because when if an aircraft declares an emergency and has to land at the nearest suitable airport, they have to, not that anybody ever second guesses you and things like that, but if something were to happen, or if you didn't do your due diligence in finding the nearest suitable airport and you were to have sent them somewhere further than what they really needed to go, and then something happened, any sort of an accident, any sort of an incident on the airplane, medically, if something happened, you have to be able to stand behind, the choices and everything you made, because they can be called into question later if something happens. So just kind of remember that this is a big part of the operational control that you and the pilot share. So that, like Garrett was saying, there's a lot of different things that determine suitability. You just have to name 3 of them here, but there's a big list, that you can list and put as your answer that you'll get right. And it, like I said, most of it's just going to depend on what the emergency is itself. So.
all right, does anybody have any questions on that or comments?
Yeah, Garrett, what's the actual FAR number on that?
I believe that's going to be FAR 121. What is it, 117? It's in that area. Let me take a look here.
If you want, Garrett, you can. I'll look it up, and if you want to press on, then I'll let you guys know.
Yeah, we'll come back to that. I'll let Adam look it up. So, So yeah, so that being said, when is a takeoff alternate airport required?
When is it?
Yes.
When I would say it's required if the origin airport is like is under foggy conditions, or if it's below minimums at the alternate airport, at the origin airport, right?
Yeah, so the you got it, but let's clean it up a little bit. So if the weather conditions at the airport of takeoff, so the origin airport, are below landing minimums, so so that one, if you do want to take the FAR number down so you get the full definition, that's the gist of it. So if the landing minimums, if the takeoff airport is below landing minimums, it requires takeoff alternate, and that's FAR 121-617. So. Does anybody have any questions on that? Comments?
Say it one more time.
Okay, so a takeoff alternate is required when the weather conditions at the airport of takeoff are below the landing minimums. And that's FAR 121-617. Did you guys see Adam's comment that just popped up for that last question? Nearest suitable airport is under 121-565.
All right, that's it.
Anybody have any questions so far?
Hey, just one other quick side note on that 121-565. The actual FAR, like when you're actually looking at it, it derives itself originally talking about engine failure. So if you have an engine failure, the FAR states that you need to land at the nearest suitable in point of time at which a safe landing can be made. However, the definition taking out just the engine failure part of it, the definition and the use of that FAR has also come in to play with all of those other things that we were talking about as well. So even though the original origin of it was from engine failure procedures, we actually use that definition in any type of an emergency situation or diversion situation that calls for landing at the nearest suitable airport. So just don't let that confuse you. If you go back and you read 121-565 when it talks about engine fail procedures, it's not so much that's obviously part of it, but that's just one scenario that it's actually using in front of this definition. But the actual from the nearest suitable point after, we're actually applying it to any situation that fits that scenario.
All right. You guys ready for the next one?
Yep.
All right. So talking again about takeoff alternates. What are the three parameters must your takeoff alternate meet in order to be legal to list on the dispatch release? So what is required for you guys to list that takeoff alternate?
So is that the 1, 2, 3 rule?
Nope, that's applied to our destination airport, but for our takeoff alternate, it's different.
Is the it's not the three things that the pilot needs for landing, right?
Nope.
is it 1 hour from departure airport? I know it's something about in still air.
Yep.
1 hour from departure airport in still air.
It's actually under the same FAR, and you've got almost all of it. There's one thing missing.
1 hour
Normal
from
cruising speed, one engine inoperative.
There you go.
Got it.
So not more than 1 hour from the departure airport at normal cruise in still air with one engine inoperative. Everybody good on that one?
Yeah.
Sorry, one last time.
Okay. The
So how
three.
did you,
Not more.
Garrett, how did you phrase your question again?
Yeah. So what are the three parameters must your takeoff alternate meet in order to be legal to list on the dispatch release? So for an aircraft having two engines, not more than 1 hour from the departure airport at normal cruising speed in still air with one engine inoperative. So all of our aircraft have two engines, so you don't feel like you have to say, well, for an aircraft with two engines, okay? Just remember that it's not more than an hour from the departure airport at normal cruising speed in still air with one engine inoperative. So why do you think, while we're on this topic to help you guys understand it, why do you think we plan for one engine being inoperative?
Because
Just for like a worst case scenario?
Yeah, so we're planning for something extremely drastic to cause us to need a takeoff alternate. That's the only time that we're really gonna, need an alternate for our takeoff airport is, an extreme emergency, and one of the most extreme emergencies is having an engine failure. So that's what we plan for, is we plan for those worst case scenarios. Does that make sense?
This might sound strange, but if one of the engines was out on the aircraft, are you still going to go through departure, I guess?
Yeah, so what happens, let me explain it really quick. What happens is we have what are called V speeds in the aircraft. So when they're taking off, you'll hear the first officer say V1. At V1, we call that takeoff decision speed, okay? And everything has to be in the green as far as like engine performance, oil pressure, manifold pressure, like all of that has to be operating in the green for them to continue with the takeoff. If they say V1 and there's something not, like one of the instruments is not coming alive, is what we call it, then at that point they throttle back the engines, hit the reverse thrusters, and come to a stop on the runway. But any point after they hit that V1 speed, they have to continue the takeoff, because at that point it is too unsafe for them to come to a complete stop on the runway. Does that make sense?
Oh, gotcha. Okay, yeah.
So does that make sense to everybody? Does anybody have any questions on that?
Well, sir, that's actually what I was going to say.
Yeah. So I mean, we're planning for the worst case scenario, and worst case scenario is after V1, one of the engine goes out, right? Or in the extremely rare and for the first time ever scenario, if you're Captain Sully, then you have a dual bird strike, both engines go out. That's so extreme, but we want to plan for basically everything but complete engine failure.
Gotcha.
So, all right. So, let's see. According to the FARs, what are the fuel requirements for a flight under domestic operations?
45 minutes of reserve fuel. Your say the question one more time, please.
Okay, what are the fuel requirements for a flight under domestic operations?
Is it it would be hold fuel, alternate, farthest fuel, or alternate fuel, burn fuel, and reserve fuel. Right? Did I say that already?
Okay, so BAR is what comprises that Minto fuel, remember? And it's basically what this is going for, but I need like the specific definition. Does anybody remember?
So are you talking about wind, weather, delay?
Nope. So
this is the one where you gotta fly the airport
Yes.
that it's dispatched, and you gotta be able to fly to the furthest listed alternate, and you also need to be able to fly 45 minutes at normal cruising speed.
yes. So the way it's worded and the way you guys need to remember it is to fly to the destination, then to fly to the most distant alternate, and then fly 45 minutes at normal cruise. Okay, at normal cruising fuel consumption. Does that make sense to everybody? So when we ask for required fuel, what are the fuel requirements? BAR, so burn alternate reserve, that's what this is required, and this is an easy way, that's kind of an easy way to remember it, but you need to break it down to the actual, like, to fly to the furthest or to fly to the destination, then to fly to and land at the most distant alternate, then to fly 45 minutes at normal cruise. Okay?
Okay.
All right. So since we're on the topic of fuel, now this is, I think that was you, Corey. What are the 4 factors for computing fuel?
That was actually me, just wind, weather, any delays, an instrument approach plus possible miss, destination, and any other conditions that could delay landing.
Perfect. Did everybody get that? So what is the acronym that we've come up with for that one?
Wow.
W with 3 A's.
Wah. When the pilot calls and starts complaining about how much fuel's on the airplane, wah.
So wind and weather, the anticipated traffic delays, the instrument approach and missed approach, and then any other delays?
Any other conditions that may delay the aircraft.
Any other conditions. Okay.
Yep. Perfect.
So wind and sorry, I'm catching up. Wind and weather, any other traffic conditions, any other conditions, anticipated traffic delays, and what did you say the other one was?
So it'll help you memorize it if you memorize it in the same order every time. So wind and weather,
hmm
anticipated traffic delays.
Okay.
So approach, so that's the second A, right? Approach, one instrument and possible missed approach at the destination. And then the last A is any other condition that may delay the landing of the aircraft. Any other condition that will delay the landing of the aircraft. Does everybody have it?
Yes, sir.
Okay. All right. So who can tell me the definition of operational control?
That one would be operational control. So it would be
Hold
the
on.
exercise of a.
Hold on. You've answered 3.
Okay,
Let's give somebody else a chance really quick.
no problem.
I like the ambition.
Exercising authority over initiating, conducting, or terminating a flight.
Yep. Perfect. Where do you find that? Does everybody remember?
Sorry, I didn't hear the answer.
Isn't that in the 1-1?
Yep.
14.
So
Exercise
go ahead.
over initiating, conducting, or terminating a flight.
Did you get that, Greg?
Yeah, thanks. I was on it. I just couldn't quite hear her answer.
Okay. All right. So, going back to FAR 65, okay. What age must you be to obtain your aircraft dispatcher certificate?
23.
Yep, perfect. And how many hours of instruction are required to obtain your dispatcher certificate?
200.
Perfect. What is the maximum speed that your aircraft can fly below flight level 100 or 10,000 feet?
250 knots.
Yep. All right.
Garrett, just a clarification. I remember on the FAR studying for the ADS, it talks about 200 knots and 250 under or in Class B airspace. Can you just kind of, I don't quite get that.
Okay, so yeah, so this is under FAR 91-117. So and that'll get you into greater detail, but if you are under flight level 100, right, which is 10,000 feet, you cannot operate your aircraft greater than 250 knots. Now, if you're under the Class B airspace, so remember that Class B airspace is like a 3-tiered wedding cake, right, or birthday cake. So if you are operating underneath Class B airspace, you're not up in it, you're below it, but you're under the shelf, you can't operate your aircraft at a speed greater than 200 knots. And that's the same as when you're in the vicinity of Class C and D airports.
So you're cutting underneath Salt Lake International under that top tier. It's 200 knots. If you're in Class B, then you're 250.
Right.
Okay.
So we'll take a quick look just to help you visualize it. Let me pull up a quick map with this on it. Trying to think of a good airport.
Wouldn't the stars usually tell you, like when you're getting close to the airport, the stars would restrict you at a certain altitude and airspeed depending on how close you get to the airport?
Yeah, but there's a lot of operation that happens that isn't on a SID or a star. Does that make sense? Like think about general aviation aircraft. General operation aircraft or general aviation aircraft like Cessnas and Beechcrafts, they're like, I would buzz through Class B airspace all the time. And not that a Cessna can do faster than 250 knots, but say I was able to, it would restrict me to that speed, mostly for safety in that, because of how high the traffic flow is in that area. So if you see here on this map, this blue circle, we're looking at a VFR chart, right? And if you guys remember when we were kind of talking about charts, this white line here represents what's under a terminal air chart, okay? So we're talking about that space just around really busy airports. We have these TAC charts, or what we call them. But this would be called a sectional chart, okay? So on a sectional chart, these hard blue bordered airports with 3 rings that you can see here, these are Class B airspaces. Anything under that blue, and we're going to go really deep into this, but anything under this blue line would be considered a Class B airspace. And you can see that the Class B airspace typically goes 30 nautical miles around your busy airport, okay? You can see here that there's these. Can you guys see my mouse right now? Okay. Yeah. You can see these altitude. These are altitudes. So what this is saying is that the top of the Class B airspace is 10,000 feet, and the bottom of this shelf here, all the way around, is 3,600 feet. Okay. So if I'm under one of those shelves, I'm not in Class B airspace. Say I'm flying at 3,000 feet in this area. I'm not under that Class B airspace, or I'm not in that Class B airspace. I'm under it, but I'm still speed restricted due to the safety and flow of traffic in the area. Okay. And like it says right here, 4,000 feet to 10,000 feet is your Class B airspace. So there's other requirements that we're going to go over when we get to airspaces that talk about like the equipment that's on board the aircraft, radio communications that are required, things of that nature. But that's the area. Underneath would be 200, but if I'm in that ring, if I'm, say, at flight level 040 or 4,000 feet, then I'd be restricted to 250 knots. Now, the only time that I can go faster, say I'm underneath that airspace, the only time I can go faster than 200 knots would be if my aircraft was unable to operate safely at or below 200 knots. So, your really big, heavy cargo jets and stuff like that, if they hit 200 knots, they're going to start stalling and falling out of the sky, right? So,
Yeah.
The other part of that section where we're talking about 200 knots would be around in these areas, this maroon shaded area. These are our Class C and D airspaces. So this would be considered a Class C with the hard maroon lines, but a Class D is the shaded maroon lines. And what that means is that when I'm operating in those areas, at or below 2,500 feet above the ground, I'm restricted to that 200 knots as well. And that's due to the traffic. They don't want you just buzzing they don't want you doing a Maverick and buzzing the tower kind of thing. It's all for safety and making sure air traffic stays separated. So, does anybody have any questions on that? And we're going to get into this a lot more in depth when we go over airspaces.
That's perfect, thanks. I just missed that question because I got ahead of myself and didn't differentiate in and under. So
yeah, so in Class B would be 250 or below 10,000 feet, and that's the question that you're going to get asked. We won't ask you about the underlying Class B or Class C airspace below 2,500 feet AGL. Like, we're not going to ask you those ones. The important one to remember is under 10,000 feet, the speed limit's 250 knots. Okay? All right. And that one is on the ADX as well, so. All right, so according to the FARs, when does a flight require an alternate to be listed on the dispatch release?
Can I go?
Sorry, say that again.
So according to the FARs, when does a flight require an alternate to be listed on the dispatch release?
This is the 1, 2, 3 rule, right?
Yep.
That's all I'm going to say.
Hold on. The 1, 2, 3 rule is when you don't have to list an alternate, or you do?
Okay. This is the way the question's going to be asked by the practical, the FAA guy. He's going to say, when does a flight require an alternate to be listed on the dispatch release? Now, your response will always be
Always.
Except.
But or except when. And now the 1, 2, 3 rule. Who wants to give me the 1, 2, 3 rule?
So the answer is always except when, and then this response.
Yep, 1, 2. Do you know the 1, 2,
Okay.
3 rule?
Yeah.
Okay, go ahead and give it to me, CJ.
Oh, okay. You don't have to list an alternate for at least 1 hour before and 1 hour after your time of arrival, and then your ceilings at least 2,000 feet, and you have 3 miles of visibility.
Yep. So an alternate is always required unless 1 hour before and 1 hour after the ETA, you have 2,000-foot ceilings and 3 statute miles of visibility, or 3 miles of visibility. Does everybody have that?
Yeah.
1 hour before, 1 hour after, 2. Dang, I forgot it already.
2,000.
1 hour before and 1 hour after
2,000
2,000 feet and 3 miles.
3 miles.
So this isn't a question on the test, but what constitutes a ceiling?
The lowest, basically cloud cover.
Okay, a little more specific.
I
What,
can't remember the specifics.
am I allowed to jump in?
Yep.
I would say a ceiling because I hear this on ATC communications all the time at my old airport, but they told the pilots to report it. A ceiling would be at the point of which like you're flying through clouds and then out of nowhere you can start seeing the ground. So the ceiling is right when you come out of the clouds, right above the airport at its lowest. That's at its lowest altitude, right?
Layer of clouds.
Okay.
Gosh, I can't
There's-
word it
there's-
exactly correct.
Okay,
but-
there is an exact wording that you have to use. So
It's lowest layer of broken or overcast.
okay, I'm going to add one more to it. Vertical visibility. So if you are forecast broken, overcast, or vertical visibility, you'll see it as a VV on your METAR. Though that's what constitutes a ceiling. So I want you guys to say when you're asked this on the practical, because you will be asked this, a ceiling is defined as the lowest layer of broken, overcast, or vertical visibility. So the reason why it's not just, cloud cover is because there's different, amounts of cloud cover. You've got scattered, you've got partial, there's different types of cloud cover that you're going to see in the forecast reporting. So broken is 3/4 of the sky is covered in clouds, right? 3/4. If you were to look straight up and look at the sky, 3/4 of the sky is covered in clouds, right? That constitutes a layer. Then if it's complete cloud cover, then that's overcast. Okay. So vertical visibility will always refer to a complete, like a cloud cover, total obscuration. So it would be, if a METAR says VV001, that means that there is a layer of clouds, complete obscuration at 100 feet above the ground.
Do they determine feet with like a laser, or like how do they determine how far away the clouds are?
Yeah, so they've got a weather reporting stations, and there's a couple ways that you can actually mathematically figure out exactly where the cloud layers are by doing a calculation, and we'll talk about it when we do weather. Not too in depth because we're not too worried how they come up with the outcome, but basically your dew point and your temperature spread, if you do a calculation, then you can figure out where using those numbers, you can figure out where that cloud layer is. But yeah, so like RVR, they use lasers to see where the obscuration is. Once it reaches a certain point of reflectivity or whatever, then that's where it'll do it. But these stations will take atmosphere readings and stuff like that and calculate where those cloud layers are.
Gotcha.
So just to kind of hit that question again, since we went off on, I'm really good at going off on tangent and tangent and tangent. So let's refocus here. So when does a flight require an alternate would be 1, 2, 3, right?
Always.
Always except for 1, 2, 3.
Yeah.
Okay. Everybody good on that? Anybody have any questions?
Yeah.
You got a question?
Oh, sorry. No.
Oh, okay. So list 5 things that are required to be in an operations specifications.
I can answer if nobody else wants to, or if nobody else out there.
Go for it.
Doing business as names, headquarters address, type of flight, aircraft wet lease, any other information the administrator determines necessary.
Yep.
I know there's a whole lot more than that. Those are just the ones I was trying to.
Yep.
Okay.
You're right on. So aircraft, you can say aircraft, registration or serial numbers, the types of aircraft you operate with, the other she said some of these, but the other business names that you operate as. So SkyWest operates as United, Delta, Alaska, and American. And we operate as SkyWest as well. So I mean, there's a whole slew of them. Headquarters address and phone number, your chain of command. Any of those answers will do. Do you remember where to find those?
I believe that it is in R91 and oh, it's not. It's in 119.
Right.
Is it? It's in 119. Yeah. Sorry.
No, you're good.
119.49.
Yeah, 119.49 is the contents of your op specs. So just pick a few off of there. You're good to go. Okay. According to the FARs, how long can a dispatcher be scheduled for how long can a dispatcher be scheduled for a duty in 24-hour period?
10 hours.
Perfect. 10 hours. All right. According to the FARs, what 3 things is the dispatcher and PIC jointly responsible for? So what are the 3 things that we share responsibility for with the PIC?
I want to say the PPDD,
Uh-huh.
pre-flight planning, delay, and dispatcher release.
Yep. Perfect. And we'll redo this question. What are the 3 things that the dispatcher is solely responsible for?
Is that the one I answered at the very beginning?
MIC.
Yep.
Yeah.
All right, so it's monitor the progress of each flight, issuing necessary information for the safety of a flight, and then canceling or redispatching a flight if, in the opinion or in the dispatcher's opinion or the pilot of command's opinion, it cannot operate safely as planned or released. That's the full definition, so just cancel or redispatch will do for us. But if you can memorize the full thing, that'll just help you down the road. All right, here we go with another acronym. Name the 5 required items that must be on a dispatch release according to the FARs.
This is
It's damage, isn't it?
departure. Yeah. Departure, alternate, the Minto, the ID of the flight, and the type of operation.
Okay. You're pretty close. Anybody else want to take a stab at it?
ID number?
Okay. I believe you said that one.
It's the number.
Trip number.
Okay, what is the A?
Alternate?
Nope.
No, it's the
Any type of
IFR,
flight.
VFR.
Uh-huh.
Yeah.
So statement of the type of operation, whether IFR or VFR. So type of operation.
I also threw in W or WX needs to be attached.
Yep.
Yeah, the weather report.
Okay. Yep. So
But
what
I thought the weather report's attached to the dispatch release, though, isn't it?
Yep, and that's what we're asking for here. So
Oh, I thought you were asking for your dispatch release form. Oh, never mind. I'm reading the same thing.
So I'm gonna type this up really quick for you guys to look at. While I'm doing that, I'm gonna ask you guys another question. Just a second. All right. Okay, if the pilot in command has less than 100 hours, high mins, so a high mins captain in the type of aircraft, what do we have to add to his weather minimums?
— 100 feet of ceiling and half-mile of visibility.
Perfect.
Yeah.
All right. That went really fast. I'm still typing. Let me ask you guys another one. Just 1 second. Okay. So 100.5 for a high mins captain. So what are the 3 things that the pilot must carry with him on the airplane to its destination?
Load manifest, flight release, dispatch release, and flight plan.
And what?
Flight plan.
Okay. So, right. So the dispatch release, flight plan, and load manifest, right?
Yeah.
Perfect. I'm almost done typing this up. Okay. This is exactly how I want you guys to memorize this one. It makes it really easy. Okay, so the D is our departure, destination, intermediate, and alternate airports. Okay. A is the type of flight, right? IFR or VFR. M is minimum fuel supply. I is ID number or tail number of the aircraft. And T is our trip or flight number. So while you guys are writing this down, what's the difference between like the tail number and the trip number?
The tail number is to identify what airplane is where, and trip number is just different route numbers, right?
So, kind of a famous flight number, Flight 92, right? That was the one that crashed in Pennsylvania during 9/11, right? So the flight number identifies basically the route that the aircraft is flying. ID number or tail number of the aircraft is the registration number of the aircraft. Think of it as like a license plate or a VIN number, right? Type of flight, remember instrument or instrument flight rules or visual flight rules. Okay. So just write it down like this, and I want you guys to memorize it just like this. This is the most condensed, accurate version of being able to recite this FAR that I've been able to come up with. Like, this is the least amount of words that you can really say and still be exact in your definition. Does that make sense?
Yeah.
So, does everybody have it written down? And when you forget it, I'm going to say, yes. Damn it. Why did you forget?
Yeah, that really is a lot easier than trying to remember this little list I have written down.
Yeah, so it just, yeah, that's the way I had some of these I learned from a guy that came and taught some of Adam's classes. And he taught us the acronym, but it really helped me when I broke it down and actually like compared it to the FAR and then just remembered exactly the acronym. So, oh, can't let you guys see this test. Okay, so we talked about the 3 things that the pilot in command has to carry on the airplane with him to the destination. the load manifest, dispatch release, and flight plan. Okay. True or false? Should a dispatcher ever declare an emergency?
True.
Yes.
True.
Okay.
True.
Should he?
Yep.
Well, depending on what it is, but true.
Yeah, so the dispatcher's basically able to declare an emergency if necessary. Right? All right. Is a dispatcher able to delegate his authority to sign the release, but not the authority to dispatch?
True.
True.
Okay. So we're able to delegate the authority to sign, but we cannot dispatch or delegate the authority to dispatch. Perfect. Okay, and
Ask the question again, Garrett.
Yep. Oh, you want me to ask the question again?
Yeah, that'd be great.
Okay. A dispatcher may delegate his authority to sign the release, but not his authority to dispatch.
Is that something that happens a lot? People saying, "Hey, will you just go ahead and sign this release for me?" When it's your name on it.
Yeah. So real world application of this FAR would be all of our dispatch releases are done electronically and filed to the gate agent. Okay. So we basically electronically sign it when we send it to the gate, right? But in the rare occasion that our system goes down or at the airport their internet's not working or whatever, and they're not able to electronically receive our dispatch release, we have to do what's called a manual release. And what happens is we'll go through and we'll read each one of the things on the chart or on the release to the pilot in command, and then we have to authorize him at that point to sign the release in our stead, basically. Because we're not there to physically sign it, and he's writing a manual release, literally like taking a pen and writing down all the information on the release. At that point, we're able to delegate that authority to sign it.
Gotcha.
We still create the release. We still are, come up with all the calculations and all the formulas and the routes and still tell them, how much fuel and everything. We just don't physically sign it. So basically we give him he's a proxy for us at that point. All right. So last question I'm going to ask you guys tonight. Well, okay, not tonight, but dispatchers, true or false, dispatchers must log 8 hours per year observing operations from the cockpit jump seat.
False.
Okay, how many hours?
5.
Perfect.
Or 2.5.
14 hours?
So, or 2.5.
Oh, yeah. Depending, it's like 14 hours, that's a random number. Yeah, so for your initial training, 5 hours. And we'll just keep it simple and just say, as long as you guys can say 5 hours, then that's perfect. All right. So, I'm kind of wanting you guys to study all that information that we just went over. and we'll take the class this next time. Or take the test next class, because I really want you guys to be able to understand it, fully understand it, and grasp it. Okay. Is that okay with everybody? We can do a quick, like, I'll send you out I'll just send you out this Word file that I just created for the dispatch, what's required on a dispatch release, so you guys can see how we receive the test, and then you guys can just type yes on the bottom or something and send it back to me. And that way we know that it's all working, if that's the part that you're really worried about. Does that make sense? So that everybody knows how the quiz is going to be sent out, how you edit the document, and then how you send it back to me. Is everybody okay?
I would definitely appreciate that, yeah.
Okay.
Yeah.
We're going to do that really quick. Let me save it really quick. I'm going to pause the recording. Thank you for catching that. Oh man, I wonder how far back we're going. But your questions on the test will be, how many, or name 3 different types of ground-based navigation. So that would be your VOR, DME, ADF, NDB, any one of those. And then you'll also have a question that is name 3 types of satellite navigation. So GNSS, GPS, and we'll go over more satellite navigation here. But yeah, so the components are 24 satellites, control ground-based GPS monitoring and control station. The user, which would be aircraft antennas and receivers. So there's ground-based systems that communicate to the satellite, and then the satellites triangulate your position relative. So GPS function, concept of ranging and triangulation from satellites to form reference point. Receiver measures distance from satellite. It requires a minimum of 4 satellites. So minimum of 4, I believe 6 is optimum to yield the 3D position, navigation, and time. Receiver, DME, bearing, ground slope, and time. Or I mean, not ground slope, glide slope. So RAIM is how we test. Receiver on autonomous integrity monitoring. So this is how we make sure that our GPS is giving us an accurate position. We use these RAIM tests in order to calibrate our GPS system. So the GPS receiver verifies usability of the GPS constellation signals through RAIM. It determines if a satellite is providing corrupt information, and without RAIM capability, no assurance of accuracy or GPS position. There's no assurance of accuracy or GPS position. So to perform the RAIM capability function, you need at least 5 satellites in view. And the way it breaks that up is 4 for position and navigation, and 1 extra must be tracked. RAIM outages. So if you're not receiving a good enough signal or you don't have enough satellites in a given area, these are the error messages. There's a couple causes of these outages. Like I said before, insufficient number of satellites, poor satellite geometry leads to a larger position errors. Change in aircraft dynamics, such as banking, can obscure the GPS satellite signal, which must be received in the line of sight. GPS IFR certification requirements. So it has to meet these specifications. Basically, it has to be, has to go through its airworthiness installation. You can't just throw a GPS on your airplane and call it good. It needs to be approved. And then it needs to be operated in accordance with the pilot operating handbook or the airframe. What is it? AFM? I want to remember the acronym. Aircraft flight manual. I can't remember. Or flight manual supplemental. So the GPS database needs to be updated for the type of operation you're using it for. And then it just has to be able to predict RAIM. So you have to do a RAIM calibration on it. And then before you fly, you have to look for NOTAMs. So NOTAM stands for Notice to Airmen. And basically you can't have any GPS outages in your route if you're using GPS navigation. So for in-route and terminal navigation, so on our aircraft at SkyWest, like the CRJs, you have to have instrumentation. You have to have backup instrumentation. So we use what's called an FMS, and basically the FMS allows us to use these GPS approaches. And in order to use a GPS approach, we also have to have a backup to that system, which would be a ground-based navigational approach. So like an ILS or a VOE or a DME ARC in order to operate at that airport and to land and use that airport. We can't do a landing solely off of GPS. So you must have an alternate means of navigation appropriate for the route of flight to the destination and alternate. Ground-based nav aids must be operational. So not only do you have to have that backup, but you can't just say, oh yeah, there's an ILS approach, and then find out that there's a NOTAM or a notice saying that the station that you're using, that backup station, is out of service. Alternate airports must have a GPS instrument approach procedure. If alternate instrument approach procedures require an ADF or DME, it must be on the aircraft. So basically you have to have the equipment to shoot that approach. So WAAS and LOS. So wide area and local area augmentation systems. So WAAS is just an upgraded version of the GPS. So like it's shown here, what a GPS gives you in a 50-foot range, WAAS can give you a 10-foot accuracy. So it just improves the accuracy, integrity, and availability of GPS. Receives 2 geostationary WAAS satellites. Receivers use the two geostationary WAAS satellites. Performance enable instrument approach procedures with GPS, WAAS glide paths. GPS precision approaches with vertical guidance. So this would be considered a precision approach. LPV and LPV instrument approach procedures. So lateral precision approach with vertical guidance based on the WAAS. And then LNAV and VNAV approaches are lateral and vertical guidance. So we talked about it when we were going over the FARs, the difference between a precision and a non-precision approach. I just said it a second ago. Does anybody remember what the difference is?
Can you say that one more time?
What is the difference between a precision and a non-precision approach? So I want you guys to write this down. Precision is lateral guidance, and a non-precision would be lateral and vertical guidance.
Can you repeat that one more time?
Okay. A precision approach would be lateral and vertical guidance, and a non-precision approach would be lateral only. So we'll look at some approaches. We'll look at approach procedures, and we'll identify which ones are precision and which ones are non-precision approaches.
And is that why precision needs more feet as far as the ceiling? And I believe that the miles are the same.
So your precision approaches are more accurate approaches. So it requires more instrumentation in the aircraft, but not necessarily there's not necessarily a difference in your requirements for the approach. So the differences are notated in your instrument approach procedures. So our minimums are going to vary according to whether or not it's a precision or non-precision approach, but that's our alternate, whether or not we need an alternate doesn't change. Does that make sense?
Yes, it does. It's just that with the studying from the FAR's precision and non-precision, I was kind of trying to put it together a little bit.
Yeah. So
maybe it's not. I don't know.
Yeah. So precision, you're going to have more accurate and lower minimums. Okay. Non-precision, you'll have higher minimums. Because you're not with a non-precision approach, you're not going to have that vertical guidance as well. Does that make sense?
Yes, it does. It kind of makes sense. I'm just trying to put it all together.
Yeah, and we're going to go over that a lot more when we actually get into approach plates and looking at approach plates. So it's just kind of some images that show how GPS loss and WAAS receivers work. So there's actual ground facilities that receive the satellite signal or receive the signal and send it to the aircraft, and then the aircraft's also receiving. So it's using both ground-based and satellite signals to provide information to to the aircraft. Does that make sense?
Yeah.
So flight support systems. So air data computers. They use pitot pressure and static pressure, temperature, or they read pitot pressure, static pressure, and temperature. It's used by aircraft systems, including the electronic flight information system. So this is giving us, this is basically what disseminates the readings from the different systems on the outside of the aircraft. It will help calculate our altitude, indicated airspeed, true airspeed, and air temperature. And when we're in RVSM airspace, we are required to have 2 of these operational. So does anybody know what RVSM airspace is?
Do we know what?
Do you know what RVSM airspace is?
Yes, I've heard of it a lot. I've heard of VSM before. I can't remember.
Okay. So RVSM is reduced visibility separation minimums. Or reduced vertical, reduced vertical separation minimums. So basically when we hit a certain flight level, which would be 290, all the way to 41,000 feet, 410. RVSM just basically means that anywhere outside of RVSM airspace, there has to be 2,000 feet in separation between aircraft, vertical separation between aircraft. When we're in RVSM airspace, that allows us to reduce that separation by 1,000 feet. So rather than having 2,000 feet flying opposite direction, we reduce that to 1,000 feet. And what that does is it allows us to put more aircraft in a tighter amount of space.
So VSM is a reduced vertical visibility minimum.
No.
Oh, sorry.
No. Reduced vertical separation minimums.
Oh, okay.
So it's only in certain flight levels, and basically it requires extra equipment other than just an airplane. You know, you have to have there. It requires that we use certain equipment to help us stay on course. Flight Director Systems combines several instruments into one display, provides easy interpretation of our flight path, and the components are your ADI, HSI, and mode controller, and then your Flight Director computer. So this is what it would look like in our CRJs. But basically it combines everything and puts it into one easy to read display. Integrated flight control systems integrates various systems into one system, just like this Flight Director system. It's comprised of airframes, FDS, and autopilot. Autopilot means, autopilot mechanical means controls. I'm not sure why it's worded like that. That's kind of weird. RVSM, you're required to have autopilot to operate in RVSM airspace. And the autopilot must control the yaw, pitch, and roll. So the autopilot works with the electrical, hydraulic, or digital system to control our yaw, pitch, and roll. So the FMS, this is our flight management system. As I was talking about before, when you're shooting GPS approaches, this is the system that allows us to do these. And we're required to have, so many of them working in order to use these approaches. Master computer interfaces with all navigation sensors. So it just basically takes all inputs and puts it into one easy to read display. And so GPS is dominant FMS navigation sensor. So it uses mostly the GPS. The CDU, control display unit. So this is just talking about this right here. So interface with master computer and provide single control point for all navigation systems. So this is just what your FMS looks like. FMS operations, electronic database. So it stores all your nav, airway, SID, stars, instrument approach procedures. It's updated every 28 days. Input into CDU. So basically, we just update this to create the flight plan. So it provides data on the display, commands aircraft where to go, and provides the LNAV and VNAV guides on an instrument approach procedure. So the interface with other aircraft systems. So not only does it provide all that routing information, but it also will interface with other controls. So this is kind of taking all these instruments on the aircraft and putting it into one. So it'll provide your fuel management, display systems, graphic weather displays, air and ground data. So the EFIS. So our EFIS is basically it replaces a ton of indicators with a single glass display. So this is our EFIS here. Or this is where our EFIS would be. And what it does is it basically takes like your manifold pressures, your APU temperatures and stuff like that, all that information rather than having its own dial allows you to put it onto this display. So it's a much easier single point system to read rather than having thousands of instruments in your cockpit. It just combines all of that into one display. So our instrument approach systems. So a Category 1 ILS. So to shoot a Category 1 ILS approach, it's instrument. You have to be instrument rated. Your aircraft has to be equipped and current. So you have to. Everything has to be current on the aircraft. And not only current on the aircraft, but you also have to be a current instrument rated pilot. So we have to go through proficiency checks, every so often as a pilot to retain our instrument rating. Our usual Category 1 approach will be a half mile of visibility or 2,400 feet RVR. And our decision height will typically be 200 feet. So a Category 1 approach is what we're going to use for our landing minimums most of the time. And that's, we have to use Category 1 approach minimums to determine our legal to go. Does that make sense? So write that down, is that our Category 1 minimums are what we use to determine whether or not we are legal to go. Did everybody get that?
Not just yet.
Got it.
So you want us to write that word for it, or what was the summary you just said?
Yeah, so category 1 minimums are what we use to determine legal to go.
Okay, I got it.
Okay. All right, so a category 2 requires that you receive a special certification. So you have to be approved by the FAA to operate category 2 approaches. Typically, you're going to see RVR of 1,200 feet and a decision height of 100. So it basically takes our category 1 minimums and cuts them in half. We're at SkyWest, we're allowed to use category 2 approaches. We're certified for it. So yeah, it's category 2 is just the important things to remember is that it requires that special certification, and not anybody. You have to be. It has to be in your op specs that you're allowed to operate and do category 2 minimums on your approach. Category 3. So this is extremely low visibility requirement. So once again, it requires that special certification from the FAA, and you have to have a lot of equipment in order to shoot a category 3 approach. So your RVR will typically be 700 for category A aircraft, 150 for category B aircraft, and 0 for category C aircraft, and no decision height requirements. So that means that basically you don't have to see a single thing and you can land. Most of your mainline carriers like Delta, United, American, they're approved for these category 3 minimums. But your aircraft has to be equipped with the special equipment. Not only does your pilot have to be certified to do the approach, but your aircraft also has to have the correct equipment to do those approaches. So we're
Is it saying that the no decision height for all 3 of them A, B, C?
What was that?
So is it saying no decision height for all A, B, and C, or just C?
So this RVA or RVR for category A requirement is 700 feet. So we have different. Let me pull up a JEP chart really quick.
Do you need us to write down the visibility of each category, or just need special certification, legal to go definition?
Basically, special certification for category 2 and 3 will do. Let me pull this up really quick. So when we're talking about these approaches, you'll see right like here, you'll see a category A, category B, category C, and a category D. So this is just depending on what type of aircraft you have, will put you in one of these categories. And category C aircraft that's where you're going to have like your 737s and even our CRJ 700s and 900s. And our Embraers are this category C. Category D would be like our CRJ 200s. And I believe your category B and A are like your prop, like your
float planes.
Yeah, I may have that wrong. I'd have to. Let me look that up on this break that we're about to take, but I'll give you the
So
actual
I guess my
definition.
question was, my question, I guess, was the RVRs are 700, 150, and 0 for A, B, and C, but then it said no decision height. So no decision height refers to Cat 3 as a whole.
Yeah. So, yeah, there's no ceiling requirement. Yeah, so right here is your ceiling. Okay, this 200 feet, that's your decision height. So that can be all the way to the ground. You don't have to have any vertical visibility in order to shoot the class category 3 approach. Let me we're gonna take a break here pretty quick. I'm just gonna show you guys a video of what a category 2 approach looks like. It's pretty insane to see from the cockpit what this looks like. Let me just look this up really quick. It's pretty, like if you were up in the cockpit and you saw this, you'd be like, there's no way. There's no way we're gonna do this and come out alive on the other end.
How did you feel about a category 3? I thought that was worse.
It is. It is. But at SkyWest, we're not allowed to shoot the category 3s. But I'll show you what a category 2 looks like. And it alone is intimidating. Basically, to shoot a Cat 3 approach, you have to have auto land and a heads-up display system. So they they can basically see exactly where that runway is with the heads-up display system, but then they're not controlling it. They're just there for backup if the system were to fail. I'm going to pull up a good video here. This will give you a really good idea of a category 2 approach. So open that up and watch that video. Everybody mute yourself so that it doesn't blur into everybody else's. But pull that up really quick and watch it, and then I'll jump back on here. So did everybody get to watch it?
Yes.
That's
Almost
pretty,
done.
Yep.
Yes.
that's pretty intense, huh?
Cool. I'm just curious,
Very foggy.
how come SkyWest isn't allowed to operate Category 3?
Because we don't have the equipment to operate it. It wouldn't.
Allowed to operate category
Not only do we not have the equipment, but it wouldn't really be cost effective for SkyWest to go to a Category 3 due to that.
cost effective.
So
Okay. And one time, we were in a big blizzard or snowstorm, and the snow plowers couldn't keep up with clearing all the taxiways, so they made like a racetrack for 'em. And ATC had to make my fuel truck go all the way to the end of the runway or the start of the runway. I had to go all the way down, and I remember holding short of the runway, and I saw an aircraft pass right next to me. And it seemed like it was pretty dense fog, so I didn't know if it was Category 2 or Category 3, but I think it was SkyWest that landed.
Yeah, we aren't allowed to operate. So, like you saw there, it said when it says minimums, and you can even hear the captain say, at that point, decision to land or something like that. And basically, if he can't see the approach lights when it says minimums, he can't see where the runway is going to be, then he'll execute what we call a go around, where he'll throttle up the engines and go missed on the approach because it's unsafe to land at that point. He has to have that visual indicator when he reaches that decision height. So yeah. Anyways, we're going to take a break here, and we'll be back at 9 o'clock. Let's just call it 9 o'clock. So.
Okay, I'm going to try and work on my email now.
Yeah,
and get you that document.
Yeah, I'll watch for it. So.
Thank you.
Yep. So for a Category A, we'd have to have 700. Category B, would be 150, and a Category C would be 0. Does that answer the question? Hello?
Yeah, it does.
Okay. Just hold on for 1 second. Yvonne, is she on? Oh, she's not on right now. She must be having computer issues. Let's see. All right, let's go back to the PowerPoint here. All right, so we got through this. All right, so what makes up an ILS? We've got, for our lateral guidance, so our side to side from the airport, we got a localizer. On our vertical guidance, we've got a glide slope. So here's your localizer. Right?
Sorry, I can't see anything. You have something.
Yeah, I can't. Yeah, I can't see it.
Okay, here we go. Man, I am on a roll tonight.
I'm just not seeing this.
All right. So for our lateral guidance, we have a localizer. This is what the localizer looks like. For our vertical guidance, so localizer is our side to side, right? So we're looking this horizontal axis right here. So for our vertical guidance, we've got our glide slope, and this is what the glide slope looks like. So this sends out a signal from the end of the runway up, and it gives us our vertical relationship to the runway. Okay, so our middle marker, when we're coming in on our approach, the middle marker, you'll actually hear it in the cockpit. Oh my goodness, my mouse is so sensitive today. You'll hear it in the cockpit when the pilot flies over the middle marker. It'll actually say middle marker. But then the other component that we use is the approach lighting system. So the DME is the distance measuring. We got compass locators, and then we've got like our outer compass locator. So we have an outer marker, middle marker, the localizer, and the glide slope. All of these give us our vertical and lateral guidance on our approach into the runway. Okay. So for the visual, just like I said, the approach lighting system, touchdown. So touchdown zone lighting, our runway center line. All of those are visual guidance coming into the runway. And for the visual, we have multiple different lighting configurations depending on the airport we're flying into. So this just kind of breaks it out a little bit more for you. So this just kind of tells you where these transmissions are done and what your instrumentation will look like on your descent. So our glide slope, like we said before, this is the basically the range, the beam, 1 1/4 degree thick, or 1.4 degrees thick. So from the center of that line would be our would be 0.7 degrees on either side at 10 nautical miles. And it's a 3-degree approach. Every glide slope will give you a 3-degree approach into the runway. Well, I should say typically. So these middle markers, this is how you'll see it identified. And the compass locators, that's how you'll see them identified. So at your outer marker, depending on if you remember those course deviation dots, this will be approximately 300 feet lateral displacement per dot of deflection. So for every dot, when you cross over that outer marker, each dot will be the equivalent of 300 feet. If you remember me telling you, as we get closer to the station, those dots, even though it's 2 degrees, regardless of our distance from there, the actual foot equivalent decreases as we get closer to our runway. So at the outer marker, average of 300 feet lateral displacement, and then when we cross over that middle marker, if there's any deflection, each dot is about the equivalent of 100 feet lateral displacement. So these are our different approach lighting systems. So this is what we call an ALSIF 1 or ALSIF 2 and an ALSIF 1. Mausers. So and then a MALSIF and ODALs. And then this is a rail. So here's you will get asked like what is Mauser, and if you look down here on this, and like I said before, you have access to this on today's lesson plan. But Mauser is medium intensity approach lighting system with runway alignment center indicator lights. Kind of a lot to say for it, but so here's your center line markers coming into the runway, single light, and then but the more complex the lighting system, typically will help us basically guide in. It's typically a bigger airport. This is what you're going to see at like all your hubs, like Salt Lake City. You're going to see an ALSIF 1 or ALSIF 2. This is one of the requirements for Category 2 approaches. SkyWest, we have to have an ALSIF 1 or an ALSIF 2 lighting system in order to execute a Category 2 approach. So this is what we call a VASI. And what this VASI does is this is kind of like a glide slope, but for a visual approach. This tells us how high or low we are in relationship to the runway. So if you see two reds, that means that you're too low, your approach is too low, and that if you were to continue on that approach path, you'd land short of the runway. If you see red over white, that means that you're going to come in right on the numbers. That's basically your ideal approach. White over white means that you're too high and you're going to overshoot the touchdown zone of the runway. So those are your visual glide slope indicators. Does anybody have any questions on any of that, or?
Nope.
All right.
Memory ache from long ago, right over red, you're dead.
Yep. And then I can't, white over white, you'll stay in flight. And then red over white, that's just right, or something like that. I can't remember all the sayings from my pilot training, but yeah. So your localizer approaches, you got an LDA approach, localizer directional aid. So it's not aligned with the runway, and the width is 3 to 6 degrees. And then you got an SDF approach, is a simplified directional facility. Once again, aligned with the runway, 3 degrees of the runway, or aligned within 3 degrees of the runway. And then the width is 6 to 12 degrees. And then you got your localizer, and yeah. Microwave landing system, ground-based navigational aid. It provides precision approach capability, and it's similar to an ILS. So it provides azimuth, elevation, and distance, and it allows for those circle approaches or arc approaches. So extremely expensive. Basically, the more complex and the more precise the equipment gets, the more expensive it costs. So RNP approaches. SkyWest is about to be able to do RMP approaches, but required navigation performance. So it's a combination of things. RNAV, you have to do RNAV with board navigation and alerting. new standard of navigation for airspace management. Navigation performance required within defined airspace. The RMP, the navigation performance necessary for operation within a defined airspace. Aircraft navigation system has the ability to monitor its navigation performance and identify if operational requirements are met. The advantages are less reliance on air traffic control intervention and or route separation. RMP approaches RMP aircraft capability depends on aircraft equipment and navigation infrastructure. So basically it allows us once again to reduce, it's a more precise approach system. So yeah, I mean, basically this is just showing you, it's kind of like a tractor beam. I mean, kind of think of it as like flying, you know, it's just a really accurate way. It gives us multiple different readings and combines different navigational aids, you know, using satellite and ground based nav aid once again to provide us our precision approaches. So the heads up display we kind of talked about. There's multiple versions of heads up displays. So this would be more of like your military aircraft. This is more of what it looks like. This is really funky. I want to say that's from like the 80s. Yeah, but basically the heads-up display, or HUD, provides a projection of navigation and air data on a screen between the pilot and the windshield. So rather than the pilot having to look down to receive the information, he's able to keep his eye on the direction of the plane. Any information on aircraft flight computer can be displayed, and the display has to be either a separate panel or eyepiece. So safety systems, radar altimeter, altitude alerting system, height above terrain. So that's the instrument that in the cockpit you'll hear the terrain, pull up, or you know, where it was saying the one that said minimums and then says 100, 50, 20, 10. It gives them that height above the ground. It provides the absolute altitude on approach, info to onboard systems. So it's relaying that information to our autopilot and our flight director. And it consists of a receiver, antenna, and transmitter. Terrain alerting and warning systems. So our GPWS, ground proximity. So this just basically reads the terrain and will notify the pilot of any terrain, like any terrain issues that are coming up. So, so what was that?
Oh, I was just gonna point out that yeah, like on some of the displays on the CRJs, your map will usually have like a number on the side of the screen, and that'll tell you like the height of the height of the mountain, and then it'll highlight that part of the map of where the highest point of the mountain is.
Mm-hmm.
So it'll say like 13.6 on the side, and then you know that that little dot that's 20 miles away on the right is that mountain that's 13,600 feet.
Yep.
You know what I mean? Yeah.
So this can be tied into our gears and flaps, and our glide slope provide advisory callouts. So help us on our approach. And then the TAWS terrain awareness uses GPS and database of terrain, RL and visual warnings. So like I was saying before, it'll squawk at you and tell if you're too low. The TAWS is required for jet or turbine-powered aircraft that carry 6 or more passengers. I guess more than 6 passengers. So TCAS, traffic alerting systems. So the TIS is a traffic information system. Ground-based service uses Mode S and altitude encoder. So each one of the aircraft in the sky will have a transponder on them, most likely, unless you're like in Idaho and some farmer's buzzing around in his little crop duster or something. But yeah, so they carry what's called a transponder on the aircraft that basically each aircraft is required to identify with a certain code on that transponder. And this system just basically tells you in relationship to the station or you where the aircraft are within an area, and it'll display anybody within the 7 nautical mile area, and it's fairly inaccurate, plus or minus 3,500 feet. So this is like your most basic traffic alerting system. So TCAS is Terminal Collision Avoidance System. This increases your flight deck awareness and prevents mid-airs. So in your high traffic areas, we're talking like RV, whether it be RVSM airspace or on approach or departure from an airport, this is going to allow the pilot to spend more time focusing on the outside of the aircraft and his procedures, because the TCAS will alert him of any aircraft that are close to him. And depending on the level of TCAS, it'll also provide him solutions to avoid the aircraft. So it's an airborne system, so it's an actual instrument mounted in the aircraft. It's not like the TIS, where it's a ground-based station that just uses transponder codes to relay the information. But this one's actually mounted in the aircraft. The antenna receives Mode S bearing, and then the Mode C aircraft altitude. So it's 2 different type of transponders that are required for this. And then it also receives the timing of Mode S. So it uses those 3 different readings to position the aircraft on the display. TCAS 1 provides traffic advisories, and it's required when you have an aircraft that's carrying 10 to 30 passengers. TCAS Level 2 has the same requirements as TCAS Level 1, but then it also requires analysis projected for flight path, issues resolution advisories, and it's required for any aircraft carrying more than 30 passengers or a turbine with a takeoff weight greater than 33,000 pounds. So if it gets deferred, meaning that there's an MEL on the TCAS, that means no limitation. Except for you can't fly in RVSM airspace if your TCAS is deferred, I thought. I'll have to check on that. That might be needing an update. So, yeah. What is going on? Oh, I guess that's the end of it. So a whole bunch of information in that PowerPoint. Like I said, if we're going through anything over the next little while or any time throughout class, it is available for you guys to go through and look at. I highly recommend that you do that just to kind of refresh your information on it. But does anybody have any questions on any of the stuff that we covered tonight? Like I said, a lot of that information isn't necessarily like need to know. Like you don't need to know, what an NDB necessarily does, but what you need to know are the things that I pointed out to you and told you to write down and memorize. Kind of important to remember too, like your primary types of ground-based navigation, VOR, ILS, localizer. Those things are key to our being able to navigate, and we're going to continue to talk about how those relate to our flight planning and navigation. But this is just kind of an introduction to those systems. So if there's no questions, then I'll let you guys go. So yeah.
None from me.
No questions here.
Not yet, anyways.
All right.
Yeah, I'll just go prepared for tomorrow, I guess.
Yeah, definitely look at those items that I told you guys to review, or that we covered in our review, and make sure that you have those down pat for the quiz tomorrow. So.
Will do.
Good. I was just gonna say, relating to all this navigational stuff, I was thinking to myself, I'm like, I wonder if I should show them my simulator, and then we can just, kind of talk about it as we're flying on the simulator.
Yeah, that'd be kind of fun.
Oh yeah, he's just got that on his computer.
Yeah, it's the 737 version, and it's like all high tech. I mean, you'll like it once I show you. It's pretty cool.
All right. Yeah, if we get some time, I'd be down. So. All right.
So Garrett?
Yeah.
I just wanted to make sure that you receive my email. I kind of have to go a roundabout way to do it, because for whatever reason I cannot, in Hotmail I can't close it out for, I don't know why. So I sent it through another email that I have, so hopefully you received it.
Okay, let me take a look here.
And hopefully tomorrow, I'm not gonna, if I'm late, I might be like 15 minutes late. I'll try and be on time as best as I can.
Okay, that's fine. I'm not seeing it, Yvonne.
Okay, from a Gmail?
Yeah, I'm not seeing it.
Hey, this is Evan. Do you see mine?
Yeah, I got yours, Evan.
Alright. Yeah, I did it a weird way too.
Yeah.
So Garrett, Garett.
Nope, Garr, double R.
Yeah. ETTURRY. Oh, you know what? I put it at gmail.com. I'm sorry. It's Yahoo.
Oh, okay. Yeah.
Okay, so that. Okay.
Well, I'm gonna get off now. Is that okay?
Yep, that's fine.
All right, have a good night.
Yep, you too.
Good night, guys.
See you tomorrow.
Garrett, for my tomorrow, did you want to send it to me and I can send it back to you tomorrow? Because I won't be in class
Yeah, I'll just send it to you tomorrow.
Okay.
As soon as I can. Like I said,
Okay.
I'm usually at work until about 5 o'clock, and then it takes me about 10 or 15 minutes to get home.
Okay, sounds good.
Alrighty.
Thank you.
Yeah, thank you.
Bye.
Bye.
Okay, and I can just, I'm sending it right now. And I am sorry to keep you.
Oh, no, you're fine.